Hi, I'm Ned, and I make games. This video is from my live stream over at twitch.tv/NedMakesGames, where I'm live Monday, Wednesday, and Friday at 9 p.m. US Eastern Time. I'd love to see you there. Alright, is this thing on? I think so. Alright, hey everybody, it's been a while since I've streamed. I hope you've all been well. Obviously I've had my YouTube videos, but yeah, anyway. Let's see. So, like I said, I redid a lot of my overlay and also my sound, basically my whole setup. So I'd really appreciate any feedback on basically, like I said, my overlay or sound or anything. So feel free to let me know. Also, yeah, these streams will go live on YouTube later. So hi YouTube if you're watching this. But today we're going to work on some grass, specifically this cool guy on Twitter, Harry. He does these tech art challenges every couple weeks, and I've always wanted to enter, but I never really had time. So the challenge this week is flower. So I'm going to try and add some flowers to this grass. I think I have an idea. I'm thinking something like this. So yeah, that's quite a lot of flowers. Basically, my plan is to take these blades and change some of them into flower billboards. And along the way, we'll have to work with some compute shaders and also some more advanced. I think I'm going to change them to be transparent instead of opaque shaders. So we're going to have to work with some transparency issues. Try out this thing called alpha to coverage, which I haven't worked with before, just read about, so that should be pretty interesting. But anyway, let's get started. Okay, I thought the music had stopped. I'm working from my compute shader, my real-time grass renderer. So this isn't the one that bakes a grass mesh, just because the real-time one I think will be a little bit better for streaming, since it, like, whatever you change pops up immediately. And from what I've been reading, I think it might actually be a little bit more efficient than the baked version, just because with this one you can do instancing better. So anyway, I want to kind of experiment with that. Okay, so the first thing I think I'll do. All right. Oh, I forgot to do this before the stream. I wanted to create a Git repository for this so that I could switch back and forth in case something goes wrong. So let me set that up real quick. Anyway, yeah, so like I said, I've wanted to enter into these tech art challenges for a long time, so I'm kind of excited to finally be able to do it. Okay, I don't know exactly what this shows on the screen, so let me switch to something real quick. In case I don't want there to be any sensitive information, but I don't think it would. Oh, well, now that I think about it, actually, I need to... Yeah, I forgot to get the git ignore, so let me do that real quick. Sorry about this. Again, this is like the first stream I've done in over a year, so there will be... It might be a little rough. I don't know what tech issues I'll have, but everything seems to be working so far, so I'm pretty happy about that. Okay, so got the git ignore, and now I'm just going to do a commit. Okay, that's much better. And I'll go ahead and switch to a new branch. Let's call it, I don't know, let's just flowers. That's fine. Okay. So thank you for putting up with that. Anyway, so now that I have the branch all set up, it's actually not showing it up here, but anyway, okay, so what I want to do right now, because this compute shader, it generates the entire mesh, like point by point. And I found out that that's actually kind of slow because the GPU doesn't allocate as much resources to a compute shader as it would to like a vertex shader. So the compute shader is kind of better if you just figure out how many points a grass mesh will have, and then you actually compute the points in a vertex shader. So I want to try to do that. So right now I'm going to just convert this shader over to work like that. So it'll have the, it'll basically look the same when that's all working. Okay, so we'll still have this source because yeah, there's a better way to do this as well, but that's kind of beyond the scope of this video. To get the source points, it's probably better. Like right now it generates a grass blade in the middle of every triangle on the mesh. It's probably better to, you know, generate this point cloud somewhere else and then feed it into here. But I'm not going to worry about that for now. Okay, so right now I have a draw triangle, but I think I'm actually going to change it so that we have just, that doesn't need a capital there. So draw, I guess point or anchor maybe. This will hold all the information for one anchor, and then from this, the vertex shader will be able to generate all the points. At least that's the plan. So let's have, okay, my pop filter always gets in the way of my keyboard. Okay. So we'll have just a position here in world space, and then also a normal in world space, and this will be the direction that the blade will grow out from the ground. Yeah, we don't really need, I think that's, well, I guess we could have a height, and then it'll also need to tell if it's a grass blade or a flower, but we'll worry about that later. But anyway, so this is going to change, be a draw anchor, and so this will be draw anchors. And then basically I'll get rid of these structures because we won't generate them in the compute shader anymore. But I think it will actually be easier, or a better idea anyway, to leave this how it is for now and do the graphic shader. Okay, so we just figured out the structure. Okay, so again, we'll get rid of these and change this to draw anchors. I don't know why this earbud keeps popping out of my ear. Okay, and so the vertex output will be virtually the same because we'll just output the position in world space and the normal in world space we'll need for lighting, and then the clip space position you always need, of course. This UV we might actually change to a real UV or a float 2 UV, because I think I'm going to make each of these a billboard so we can have a transparent texture. So while we're doing this or updating, I think I'll go ahead and do that. Yeah, so this is different now. Okay, and this will be a little different as well. So the compute shader will basically tell the graphic shader how many vertices we want to render in this mesh. And we'll basically have to decide ahead of time how many vertices are in each anchor. I think for now, let's just make each of them a quad, so there'll be 4 vertices. Maybe I think we'll need to add more to have wind look good, but let's not worry about it for right now. So I'm gonna take this draw anchor, and then we'll look into the draw anchor's append buffer. Okay, and the index would be the vertex ID. And this is something that you can pass or Unity can pass into your graphics shader. And it basically just gives a unique ID to every vertex in the mesh. So again, we're going to assume that every 4 vertices. That's true. I'm not sure. We'll have to just play around with that, but yeah. So every 4 vertices will be part of this blade. So yeah, the vertex ID divided by 4 is the blade, or the index for the blade, and then the vertex ID would be, I don't know, something like, let's say vertex n blade ID is just the vertex ID modulo 4. Oops, if I can find the D. There we go. Okay, so of course, most of this we're going to have to change as well. Let's see here. So, okay. So let's just go line by line here and see what we need to update. So this part figures out a position and a normal from the source triangle. So we'll still do this. Tangent space to world space. Yeah, I guess we can still use that, but it might be a little different. In the graphics shader, yeah, we could even include that matrix in this draw anchor, but that seems like a lot of my preview just flickered, sorry. It seems like a lot of data to include in this structure when we don't really need it. Okay, so anyway, we'll have the blade dimensions. I guess we should pass that. Yeah, okay. I think I'm going to go ahead and pass like a lot of data at first, and we can always bring down the amount. So yeah, let's have a dimensions and a rotation. And then maybe we'll need to have a curvature. But let's not worry about that right now, I don't think. Okay, so this dimensions. Look, let's go ahead. Okay, so for every triangle, yeah, we will generate 1 anchor blade. So let's see here. Okay, so draw anchor, and we'll just initialize it to default values. Okay, so the position can actually be the position world space value that this function just made for us. And same with the normal, because it's sticking outward from the triangle on the source mesh, which is how we want this blade to grow. Same with the dimensions. We could just use the output from here. And so at this function, oh yeah, I can't do that in HLSL. This function, okay, so it takes a position and then it generates a random number based on it to do a random width and height. So technically we could do this in the vertex shader as well. But I don't want to, because we'll probably vary these dimensions based like on what type of flower or grass blade we're generating here. So I think like I said, I'll just pass maybe more data than we need. And then once we see that we can optimize things, then I can pull it back out. Okay, so this twist matrix. Okay, so this is making a matrix to rotate the grass blade around a random angle based at this world position. Like I said, I don't really want to pass a whole matrix because that's like, this is 9 floats. Yeah, so I'll just, I think for this one, we'll just pass the randomly generated angle. Which I think I just called it rotation. Maybe I should call it twist rotation. Oh, I actually didn't update the structure here, so let me do that. So twist rotation. Okay, so anchor.twist rotation will just be this random value. And okay, so this will generate the matrix maybe in the graphics shader. Yeah, generating an entire matrix is kind of a lot of work, but I guess we already did it here, so maybe it will be fine. You could technically optimize this, but okay, so this is rotating in tangent space. Okay, so that's okay. If we want to convert from tangent to world space, then we're going to need to have also a tangent vector here, which I guess is fine. Let me see. Float 3. Because you need, again, to convert from world space to tangent space, you have to have 3 yeah, you need to have at least a normal and a tangent vector, and then the tangent vector has to have a sign in the fourth component that tells whether the bitangent, which is the third vector, is either left hand or right hand rule, basically. Okay, so okay, so I don't actually generate. How do I do? Oh yeah, so here I make the tangent to world space matrix, which I guess I actually don't even need that in this. In the compute shader, I need the tangent vector and the normal vector. I think that's in here. Oh, that was the wrong helper file. Yeah, so I have the, okay, so I make a tangent by, oh yeah, taking this first and second points of the triangle. Okay, and we can always, okay, so let's change this function a little bit here. So we get the center and the basis, but we don't actually need the tangent space matrix. Although, it's funny, I said I didn't want to pass a matrix to keep things from getting too big in this structure, but so I'm having to have the normal, the tangent, and the a twist rotation, so that's already 8, and then I could combine these all into one matrix. And it would only take one more float, because it would be 9. Okay, you know, why not? Let's try that. I've never done that before. So this will be tangent to world. Okay, so now we don't actually need this normal vector, but I don't know. I'll just leave it. Can remove it later. So we'll just pass the position and the tangent to world. Let's see. Except I can go ahead and add the twist into it. Okay, yeah, so the dimensions we can go ahead and do there. Okay, and the twist matrix. Okay, so I can't actually, yeah, unfortunately I can't add the bend into it. So let me think here. Because the bend changes depending on how high up on the blade you are. So, okay, so things happen. Okay, so actually, yeah, this will be fine. Because I was going to see the order that this is applied, because we couldn't pre-multiply the tangent and the twist matrix together if I had to apply bend in between them, but the bend is applied first. So we can do that in the vertex, the vertex shader, and then go tangent to world space, and then we can deal with wind. I don't know if we'll use a matrix for that. Okay, so I guess I'll need to pass the bend. Yeah, the bend angle. I think it's max. I'll just call it the bend angle. Hey Schultz Cole, thanks for stopping by. How are you doing tonight? All right, so okay, yeah, we don't actually pass that here. So I make the matrix. I'm gonna get rid of some of these comments because they'll probably be out of date anyway. So we can multiply this with the tangent to world space matrix and pass it into the anchor. So tangent to world equals mul tangent to world space, and then the twist matrix. Okay, and I'm calculating the twist rotation twice, so I'm glad to hear that you're doing good, Schultz Cole. How's grass and flowers? Well, haven't done a whole lot yet right now. It's bugged, but I'm working on optimizing the shader right now. Oh, hey, Crychair. Glad you could stop by. How's your night so far? But yeah, so my idea, well, it's a shame I just got rid of those grass blades, but I want to basically turn some of the grass blades into flowers. But to do that, I need to change the way that they're generated. So that's what I'm working on right now. Working on flat shaders now. Oh. And struggling working on your website. Yeah, I know. I never got into web development, so it took me forever to make my website. Okay, so this bend, we can leave this and just pass it, I think. So anchor dot bend angle. So I think that's everything we have to pass in here, because I'm gonna calculate wind in the vertex shader, and yeah, we probably won't even do LOD anymore for now. Okay, so I'm just gonna comment that out. And so all this won't even be here anymore, but I don't want to delete it in case I need it for the Vertex program. Okay, so I changed this structure again, so let me copy and paste it. So I can send it over when you're done. Oh, sure, I'll take a look at it. Like I said, I can't really comment too much on like web development code, but I can at least see what I think of the UI. Oh, okay, so we have the, okay, I don't need this angle axis anymore. So I have the vertex in the blade, and so from this we basically need to figure out the row and the column for each vertex. And from that we can construct a tangent space position, and then we can multiply that with this tangent to world, and then we'll get a world space position. And then we can apply wind and everything and feed that into the fragment function, which I'll probably update this too, but for now it's fine. Okay. So like I said, let's make a UV first. And then I can change that to a tangent space position. Okay, I'm gonna just hard code some values right now, which probably isn't the best idea, but just for testing, we can always change it. So vertex 0 and 1 will be on the bottom. Oh yeah, well this is actually the U coordinate, which would be left and right. So we want vertex 1 and 3 to be 1 and 0 and 2 to be 0, so I can just do modulo 2. And then for the V coordinate, we want 0 and 1 to be 0 and 2 and 3 to be 1, so I can just do an integer division by 2. Okay, and now that I have that, I can transform this into a tangent space position, which... Okay, so I want to center the U coordinate, and yeah, center the U coordinate, but then the V coordinates, it needs to be 0 at the ground. Okay, so let's see. So that would be UV minus 0.5, or UV dot X minus 0.5, and then UV dot Y. Okay, and times the anchor dot dimensions. Okay, and now I need to... Oh, right, so I need to... Okay, I need to combine this bend angle into the tangent to world matrix. To do that, I first need to generate the bend matrix, which is right here. Okay, I have this curvature, so I need to move that up to the graphics program, or graphics shader, I mean. Yeah, so blade curvature, let's just delete that from there because we don't need it. Okay, and so this will give us the bend matrix. And then, so that, remember that this vertex program runs once per vertex, so we don't have to worry about... Oh yeah, this should be uv.v. You don't have to worry about like calculating a different tangents to world matrix for each point like we did here. Oops. Like we did here, because the function just runs once per vertex anyway, instead of once per blade like the compute shader. So we'll need another matrix. This will be the actual tangent to world matrix, and we'll multiply the anchors tangent to world by the bend matrix. And again, with matrix rotations, they're applied in reverse order that they're multiplied. So the bend matrix happens first, which we want because it is in tangent space, and then we convert that to world space. Okay, so let's go ahead and fill in some of this stuff. So the output position, world space. Let's not just save it right there. Let's do this. And I always forget if points are supposed to go before or after a matrix. I know it's depends on if it's column or row major, but all right, so it goes after the matrix, at least the way that this has been generated. Oh, right. Okay, so now we have the world space position, and we can just pass this to the fragment function through this output structure. And the normal, we can actually... Okay, so this is... Okay, there's probably a better way you can do this, but I'm just going to do it this way because it's, you know, not prone to errors. I think you can extract the normal out of the tangent to world matrix, but I don't know that formula off the top of my head. But anyway, so we can get the normal in world space just by multiplying 0, 0, 1 in tangent space with the tangent to world matrix, because the normal by definition is in the z direction. So now we have that. We just pass that in. And yeah, remember for grass, it looks better if you just have the lighting normal point straight out from the terrain instead of straight out from the blade. So that's what this normal is doing. And then, okay, so we'll pass the actual UV this time instead of just the blade height. And then the clip space position, we can just use transform world to clip space. Okay, so it might work now, actually. Let's see. Okay, so this interlocked add stores the number of vertices per instance, and right now we just have one instance. So yeah, there's this just counts the number of vertices. So again, we said the number of triangles. Yes, we can get rid of all of this. So basically, every time we generate one grass blade, which right now only has 4 vertices, we can just pass 4, and so this will add 4 to this counter every time this runs. Yeah, and I can get rid of this function. Yeah, all this. Okay, and yeah, we could get rid of the setup blade point and figure transformation for height and all these functions, but I'll leave them for now because I think I'll need at least this wind calculation. Okay, so right now we only added the blade curvature. So let's add a property for that here. So blade curvature, float. I'll just set it to 1 for now. And okay, so I need to update the C# renderer because yeah, a lot of this is not needed anymore. Yeah, I think it will. I'm not sure which of these errors are current. Let's see. Oh, okay. So I need, yeah, let's just comment this out. It's complaining that this variable is not defined anymore. Okay, unrecognizative. Draw vertex. Okay, I think it's saying that this kernel is invalid, so it's like saying it can't access the kernel. But before we worry about that, let me go ahead and update this class. So we can get rid of a lot of this. I guess we can keep the max bend angle. We don't need the segments anymore because that will be, well, maybe we'll add it back in later, but I'll get rid of it for now. The curvature goes on the graphics shader. Okay, this dimensions stay. All the wind stuff is going to go in the graphics shader, so I'll just delete that for now. And yeah, like I said, I don't think I'm going to do LOD maybe in the future. Okay, that's all good. Okay, so the source vertex. Oh no, this is fine. This is the structure for the source and not the output. So this draw is what I need to update. Okay, so the vertex triangles. Okay, so what we have here, we need to count up all the bytes that are used in this structure, if I can get to it. So this one. So we have 3 for the position, 9 for the tangent to world matrix, 11 for dimensions, and then 12 for the bend angle. I usually break it up just to make it a little easier to remember. So 3 plus 9 plus 2 plus 1. Okay, so yeah, there's that many floats in the draw stride. And that you have to do that because you have to tell the compute buffer how big every element is inside of it. Because basically, compute buffers don't know anything about what's inside them. Okay, so blade segments. Yeah, we don't need that stuff anymore. So draw buffer. Okay, so I'm trying to it's trying to say how many anchors I'm going to make. Which okay, I'm just gonna hard code it for now. So we do, well, yeah, we do 1 anchor per triangle. So yeah, I could just do that. Oops, didn't mean to delete that whole thing. Oh, actually, okay, so these have been compute buffers, but in the time since I've made this script, graphics buffers are just better versions of compute buffers. So I'm gonna just change them all to graphics buffers. They're basically the same as a compute buffer, but they're more stable, and you can use them. Well, you can use them as an index buffer into a. Oops, I accidentally changed this to a graphics buffer when it should be a compute shader. But yeah, you can use the graphics buffer as a an index buffer into a graphics shader, which is kind of cool. Supposedly, they're eventually going to let you use it as a vertex buffer as well, which will let you be able to use like a normal shader, like a shader graph with a procedural draw, which would be cool. Hi, NTT Live. Is this trample upgrade for the grass you're working on? I might do trampling, but right now I'm just adding flowers to it, and I'm gonna try a different technique that should be more efficient because it's allows me to do like instancing better. Anyway, so I need to change. Okay, so what's it complaining about? Graphics buffer. Oh, right, I have to change this. Sounds great. Video about this next Wednesday? Actually, I probably will make a video when I'm done with this. But I'll upload this whole stream to my second channel as well. So if you can't stay for the whole thing, that's fine. Okay, so all right, they did change the order of arguments in here. So I think I just need to say that this is a structured buffer. Graphics buffer target structured. And then it has the length and the stride, and it can get rid of all this. Do the same for here. Okay, and so this draw buffer again is an append buffer, and graphics buffers do support that as well. I think it's just the append type, and change that. And then the indirect arguments. I think there's an indirect arguments type actually. Yeah, right there. Okay, so oh, right, I deleted the stride. Or wait, the size. So yeah, there's just one in there. Okay. One indirect argument structure. Okay, so now here we're trying to find the kernel. So what? Oh yeah, so I need to delete a lot of these variables because the compute shader doesn't need them anymore. So I don't need curvature. You don't need anything to do with wind or LOD. Okay, alright, so this is setting the draw buffer onto the material. I was gonna say I might get rid of this instantiated part so that I can update the material in real time, but then I couldn't have multiple. There's a better way to handle that anyway, but I'll just leave that for now. Okay, so the bounds. Yeah, we'll still need this. I think the rest of it is all fine. I actually don't need the time anymore. Because that was for wind, and we're going to do that in the graphics shader. I need local to world, and I don't need the camera position. So let me remove those variables from here while I'm thinking about it. I could just... It's gonna... I was gonna say, if I delete all these variables, it's gonna complain that these functions aren't valid anymore. But maybe that's okay, I can just comment them out. And I don't need this. And I don't need these defines. So yeah, the get number of segments I can comment out, as well as this get wind axis. And set up blade point. Okay, so with that, let's see what errors Unity gives us. Oh, quite a bit actually. The name max blade segments does not exist. Oh, I forgot to save my changes there. That's kind of important to do. Okay, let's just clear this. Okay, argument 4 cannot convert from a graphics buffer to a compute buffer. This should accept a graphics buffer, but maybe they have different argument orders. Draw procedural indirect. Yeah, see this one right here. But what does it... Oh wait, that's just an index buffer. Okay, so... Well, that's annoying. So for some reason you have to use a compute buffer to pass the indirect arguments. Unless I use draw instance indirect. Oh yeah, but I'm not drawing a mesh, I'm drawing procedural, so... Okay, well, if they're going to make us use a compute buffer, I guess that's okay. It doesn't really make much difference to me, it's just I thought, like I just told you, I thought graphics buffers were a completely better version of a compute buffer, but apparently you at least need them. You need a compute buffer to be the indirect arguments for draw procedural. I'm a little I'm confused by that, but I'll look it up out of the stream. Okay, so indirect arguments. For some reason my earbud keeps falling out, I don't know why. Okay. Now it's saying procedural grass renderer invalid kernel index. Okay, well that tells me that the graphics shader isn't compiling. Okay, yeah, so undeclared identifier, tangent space to world space right here. But it's right there. Oh, the capital S. Okay, so that worked. Now it's saying undeclared draw anchors. Okay, I forgot the S at the end of the structured buffer. Incorrect number to numeric. Oh yeah, so that should be a float 2. This should actually be a float 3. Okay, this is kind of annoying because this is in Z. Are you worse than 11-year-old with syntax? It seems I might be in some ways anyway. Poor guy. But, okay, so, yeah, because this is the X and the Z coordinate. And then the dimensions. Yeah, so anyway, I need to change this. I never know the cleanest way to do the syntax, but I need to change this from X and Z to a 3D vector. Okay, so this would just be float 3, and then I'll take this 0. Okay. Yeah, I wish there was an easy way to use a swizzle operator to do that kind of thing, because in Unity, I tend to do this a lot in Unity because the Y direction is up. But actually I'm doing it here because our grass plate is completely flat in tangent space, but anyway. Okay, so max bend. Okay, so this is complaining, yeah, that the max bend doesn't exist, and that's because I needed to use the variable, or the value that's in the anchor. Invalid subscript V. Oh, right, and you can't use V in a UV, you have to use X and Y. I'm kind of surprised by that, actually, that they don't let you use U and V as a subscript. Okay, and now this is saying angle axis 3x3 isn't defined, and I think that's because in the graphics helper file I don't have that function. It's only in the compute helper file, so that's easily fixed. No anchors. Okay, yeah, no S there. Okay, it seems like I typed it with an S multiple times. Incorrect number of arguments to... Oh yeah, I forgot the 3. Okay, so I think it cannot implicitly convert from constant float 2 to float 3. Let's see what that's about. Oh yeah, so now this is saying that this UV is a float 2 instead of being, it used to just be a float. So we want to lerp here based on the V coordinate. So again, I could just use Y if I can find the key. Okay. Okay, now it's saying implicit truncation of vector type. Oh, that's weird. So I had this variable defined, but I didn't actually use it, but I could just delete that. Okay, so now it's still saying that the kernel's invalid, but I think that might just be because I need to like press play to refresh it. Apparently not. Now it's not giving me any errors. Okay, this is always fun to debug, so hopefully it doesn't take too long on stream. I want to open the frame debugger and let's see if our compute shader runs. It seems like it does. Number of source triangle. Oh, okay. I was gonna say, why is there? It's saying that there's 5.7 to the 10 to the negative 42nd power, but that's because this is actually an integer, and it's converting from integer to float. So this is not the actual value there. But anyway, so the compute shader does run. And then we draw the opaque objects. Is this drawing? That's drawing the lit shader. I'm not sure. Oh, that must be the ground. Okay, it says draw procedural there, but it doesn't look like it's actually drawing our procedural mesh. Oh, right here, draw procedural. I don't know why I didn't see that. Okay, so obviously nothing is being drawn there. Doesn't even show any variables. That's kind of strange. Oh, but now that I think about it, I didn't update the material here, so this blade curvature. Oh, it is at 1, so that shouldn't be the issue. You know what? I'm gonna restart this just to see. I've had that happen to me before. Okay, good. My internet has stayed pretty strong, so. All right. Okay, so still nothing. How can I test this? What's the easiest way? Okay, well, I'm not getting anything, so can't like output a color and have it print. Let's just make it as simple as possible. Excuse me. You know what? I think the best way might be to just download the data inside the structured buffer and see what is inside. It'll be super slow, but that's okay. Okay, so here we'll dispatch the compute shader, and then let's see what. Okay, no, that's all fine. I wasn't sure if I needed to update any of these arguments, but okay, so we have actually let's see how many well, actually we kind of know. I was gonna say let's see how many vertices are in the argument buffer, but I guess we should make sure because that could be an issue. Okay, I don't have a structure for it here. I'm just trying to think about the cleanest way to do this. I need to make a structure for the indirect argument buffer. If I can type it correctly. I really need to figure out a better. I did this the whole time I streamed before. My pop filter would always get in the way of my keyboard. But anyway, so indirect args. Okay. I guess I can copy this from the compute shader. I'll need to add a public variable to each. So they're all unsigned integers. Okay, and so we can download this out of the Args buffer by just calling Args buffer get data, and I have to pass it an array. So indirect Args. It'll just have one value in it. Okay, so now that we have that, let's just print it. Debug log indirect args. We'll use the fancy printing syntax here. Okay, so args 0 num vertices per instance. That's really all we care about. But I guess I'll just print out the number of instances to make sure that that isn't doing anything weird. Okay, this is gonna run like every frame, but that's okay. Okay, so there is a value there. It's hard to tell for sure if that's right. Actually, I can see how many triangles are in the mesh. Okay, so about 12,000 times 4. So that does check out. Right? Trying to do math. 12 times 4 is yeah, 48. But then it adds on this. So that actually does seem a little high, but I guess I could get out the calculator and check. Okay. Oh, but I was reading the indices anyway, so it's 40,000. Okay, so that is actually right. 40,050 or 4,050. So 4 times 4 is 16, and then 50 times 4 is 200. So okay, so that checks out. Well, that's good. So we know that works. Let's do something similar, except this time I'm going to look at the like what's inside the anchors. And this will be a little bit too much to print out, but we can print out. Usually you can just print out the first one and see if the data makes sense. Like, you know, a lot of times what'll happen is I'll do some math wrong and these will be like not a number inside, or like which would mean I had divided by 0 or something. And if that happens, then you know nothing would display because the graphics card is smart enough to discard any vertex with an invalid number. Okay, so draw anchor args. I wonder if it would get mad at me. I'm just gonna download the first one. I'm not sure if that will actually work. It might complain that it's too small to fit the buffer. If that's the case, then I can download the whole thing. But so get data. Oops, this isn't args. This is anchors. Okay, and then debug log. Yeah, just in case this isn't clear, you don't want to do this for a final game because every time you get the data from a buffer, it's extremely slow because the CPU basically has to sync up with the GPU, which they don't really like to do. So basically one or the other is just waiting until they're both at the same position. But this is fine, of course, for testing. Actually, this is be anchor 0. Okay, so let's do position. Well, it could be any of these values could be causing the issue, so I guess we'll print them all out. 0 dot tangent to world. Dimensions, and then the twisting. Or bend angle, I mean. Okay, so let's see if this makes sense. I guess I'll just... Let's pretty this up a bit. So we'll have position. A matrix. Oh. Dimensions and insert a new line there. Bend. Okay, so anchor 0. Okay, so something is wrong because everything is 0. Which doesn't make any sense. Well, I mean, obviously there's an error, but that's not what's supposed to happen. And Unity is also smart enough to make sure that it waits to download this until after the compute shader is done running, so it's not like we've downloaded the data before the compute shader has finished. So you don't have to worry about that, thank goodness. Okay, so let's see here. Why could it be 0? Well, okay, since the position is 0, we don't actually do anything with that except here. That is a little strange because I didn't actually change any of this data. Maybe local to world didn't get set right? Okay, it is read write enable. That tends to cause issues when it's not. Oh, actually, yeah, did I delete the... Oh no, it's right here. Local to world. I was going to say, did I delete the part that we upload the matrix? So no, that's right. Okay, one thing I'm going to do, just to make sure that this isn't something silly. Okay, so we have the number of source triangles. I'm going to save that, and I'm just going to download the whole data. I don't know what's happening, like if it's not downloading because the buffer is too small to contain everything. I'm not sure. Oops. Let's just make sure that that's not the issue. That's fine. Okay, so now we know, yeah, we have one anchor per triangle. Okay, so now download the whole thing, but we're still just getting the first one. Okay, but it's still 0. So something is not getting set. Oh, okay, I think I did something really silly. I think I did not append the anchor. So basically we're generating it, but not setting it in the buffer. So, oh, right. And actually, since we know that we only have one anchor per blade, I actually don't even need this to be an append buffer. But I think I'll leave it because we might generate more for flowers. So in that case, we wanted to have a variable number. But yeah, so we don't actually have to have this as an append buffer because we could have it just be read write and then we generate one anchor per triangle. But anyway, so append anchor. All right, so that was pretty silly, but should be good now. Okay, so it's saying that there's an error because it can't find the kernel. Oh, but it should be working. Okay, let's clear it and press play. Okay, so there is something wrong. And not to mention everything is 0. So property draw anchors is not set. Did I? Oh, I spelled it wrong, I think. Yeah, draw anchors. Okay, so now there's something else. I'm just going to copy and paste. I don't know. Oh, this is actually wrong. So this should be draw anchors. The property, okay, and then in the C# script, did I rename the variable? Yeah, this is still draw triangles, so it should be draw anchors. Okay, so now it seems like it's happy. Okay, we're getting some data. So the position, yeah, and a bunch of random stuff. I'm just making sure that there's no like not in numbers or zeros that shouldn't be, but it looks like everything is working. So okay, so I think I'm good. We're good now. Oh, but actually there's still nothing on the screen. Let's try just entering play mode. Huh, okay, so we know that this data makes sense. So there must be some problem in the graphics shader. Oh, that's not the graphics shader. Okay, I'm going to make sure that I set this correctly because that was something that happened before. Let's see. Yeah, I didn't rename that either. So that might just be the error. Okay, so yeah, now we actually have something on the screen, which is good because we can try to fix whatever the issue is. Okay, so I actually know the reason or the issue here. I forgot. So basically all the blades are on the origin, and that's because I forgot to add the anchor position to the position world space here. So this is anchor dot position world space. Okay, there we go. Now there's still something wrong because we can see there's tearing. And I think that's because yeah, I think it's because the tip of each blade thinks it's connected to the next one. And I'm actually I'm trying to think how I can fix that issue. Yeah, I was a little worried about that. Let me see. So when you draw a procedural, you can pass an index buffer. So maybe that's just what I'll have to do. Let me see, right? You can pass index buffer. I think that's why it might be better to do a draw instance mesh. So that way I can just draw the mesh multiple times. But yeah, the index buffer is right there. But I guess we can generate the index buffer. It's not like it's going to be difficult to do. Because I think right now what's happening is it's thinking that everything is one giant triangle strip. So like the last 2 indexes, it thinks it's connected to the next one. And so right now it's kind of all the grass blades are making one giant ribbon, which obviously is not what we want to happen. Okay, so let's go ahead and make this index buffer. Like I said, it might be better to do draw mesh instanced. But I haven't played around with that too much, so I don't really want to do it right now on stream. Okay. If that's the case, it'll be way easier if we don't use an append buffer. Right? Yeah, because the buffers have to match up. So in that case, let's just, like I was saying, it doesn't have to be an append buffer. And if I want to have a random number of flowers, then I'll have to think of some other way to do it. The mesh instancing. Okay, so now this won't have a counter value because it's just going to be, yeah, just the number of source triangles. And now I'm going to have draw index buffer. And so this is, again, it's just, you know, the triangle buffer for the mesh basically just tells you which vertices are connected. And we're going to just generate the same thing for our grass mesh. Okay, so draw index buffer. Actually, I wonder. Well, okay, I was gonna say, I wonder if I have to do this index. No, I think I do. Okay, so sorry, I was thinking that I wonder if I have to do this index buffer, like basically like I'm making a mesh and then I can repeat it multiple times. But like I said before, we only have one instance, so I basically need to put all the vertices in here. Okay, and this is just the size of integer for the stride. Okay, and so each source triangle will generate one anchor, our grass blade, and each blade right now has 2 triangles. So it will be so 6 indices altogether. Because each triangle has 3 indexes or indices. And now I need to add the buffer to the kernel. So draw indices. And now I can just, okay, I gotta destroy it here. Yeah, and I'll go ahead and comment that out. And then I can pass the index buffer here. Yeah, I'm a little confused about how this works together because now that I think about it, the index buffer tells you how many vertices are in the mesh. Well, I guess it doesn't. Yeah, so this just tells you like how the vertices are arranged. I guess you still need the argument buffer to tell you like how many vertices to create total. Okay. This has been quite a bit of programming. I was hoping to get a bit more into art stuff, but everybody always asks for more compute shaders, so I hope this is a little interesting. Okay, so again, we can't append here. We will just set this value. So it will be, okay, let's change that to, so the anchor index is the id.x. And this will just be what we pass here. And then I need to change this to a read-write structured buffer, which just means that you can write to it. And this is safe to do even though our compute shader is multi-threaded, because only one kernel will ever write to each index. So we'll draw indices. Okay, so I'm probably gonna wind this wrong. Okay, so the triangles start. Okay, this is actually different for our output triangle. So output indices start, and that's because there's 6 indices per blade, which, as opposed to being just 3 per blade for the source triangle. So yeah, it's actually a little bit reductive, but so the first triangle is just the first 3 indexes. Okay, so this is actually kind of interesting. So remember, the keys are like an index. It's kind of confusing. Or a triangle point index, and then the values are a vertex index. So the output vertex is actually, since we have 4 vertices per anchor, it's actually different. Okay, so the first triangle is just the first 3 anchors. And then the last triangle, okay, so if it's 0, 1, 2, 3, they have to go counterclockwise. So 0, 1, 2, and then 1, 3, 2. Hopefully I got that right. All right, and then we could do this in a loop, but I'll clean that up later. Okay, so now we've set all the indexes and the anchors. Let's see if the grass looks better. Ooh, nothing draws. Okay, so anchor ID. Oh, yeah, I used index here and not ID, so that's this issue. Yeah, this should actually be the out vertex start. Got my variables mixed up there. So it's giving me null reference errors. Okay, let's just clear that. Okay, okay. Oh, you know what? Actually, what is giving me the null reference? So it says the source vertex buffer doesn't exist. Okay, they're actually different. Okay, let's look at the. Okay, so the compute buffer and the graphics buffer, our compute shader and the graphics shader don't have any errors. But obviously something is not right. Let me think here. Let's look for any silly errors. So draw anchor, draw indices, still add for. I guess I can make sure that I named everything correctly. Okay, so I passed that there. Okay, so it's set, and then I create the buffer. Okay, and there's that. Yeah, so the index buffer goes after the topology, so that's right. Let me just restart Unity, because that was the issue one time, and I spent like 30 minutes trying to get it to work when all I had to do was restart. Okay, so yeah, something is not right. Let's... how do I want to... I mean, I figure that our data is correct in the draw anchors anyway. So I guess the logical thing to do would be to check draw indices. But I don't really know how these values could be wrong. Maybe I'm not using the index buffer correctly. Okay, well, let's just try it out. So I'll download the indices. And let's print out the first two triangles. Okay, sorry. Draw triangles, indices. Again, this is probably better as a loop, but I don't want to deal with a string buffer. So when we print this out, it should say like 0, 1, 2, 1, 3, 2. Let's see if that's what actually pops out. Okay, that's exactly what pops out. Which makes me think, maybe I'm not doing the index correctly. I'm just going to print this out one more time to make sure that I didn't mess something else up. No, the values are the same there. This is one bad thing about working with compute shaders. They're pretty hard to debug. But it seems like all the output from the compute shader is set up right. So I'm a little confused about what the issue might be. Okay, so again, we set everything there. And we know that the anchor is set up correctly and that the triangles are at least... So we know at least one is. Actually, okay, let's turn off... Oh, culling is off. I was going to say, maybe I wound them the wrong way and I just can't see them. Let's turn on... Maybe the frame debugger will give us some more info. Plugin event. I don't know what that means. Okay, so it's at least showing up. Oh. I wonder if this is messing it up. Well, I guess not, because everything showed up correctly, but I don't have to set the counter value there anymore. That might have been. I don't know. Let's see. Right, because I did set this to be structured. And I think that's correct for a read-write. Yeah. And then, yeah, they both are read-write buffers, right? Yeah. Okay, still nothing. Okay. Let's see. Okay, so draw procedurals there, but doesn't really give us any information about it, which is a bit of a shame. It is kind of weird that they don't even show the shader. I wonder... I wonder if it's not showing the shader because it's not rendering for whatever reason. Okay, I'm gonna... Let's turn off... Go back to where it was all just one ribbon. And let me see if it still works then. Because then I know it's something with the index buffer. Okay. I don't know if that's a good or a bad thing. So the index buffer is not working. I wonder if I'm just not filling it correctly. Yeah, it seems like everything is good. Don't like to do research on stream because I know it's super boring. But I'm not sure what this error could be, so I might pivot to another project. But let's see. Let me just look something up real quick. Maybe I can find it. I don't know. Graphics dot draw procedural indirect. I'm not. Okay, so draw a call on the GPU without vertex or index buffers. Oh, that's the wrong one. So without a vertex buffer, the amount of geometry to draw is read from a compute buffer, generating an arbitrary amount of data from a compute shader and then rendering it, blah, blah, blah. Has to have 5 integer numbers. Okay, so it's different. Because this... Yeah, it's 4. Okay, so that might be our problem. 5 integer numbers at the given args offset. Index is the count per instance. The instance count, the start index location, base vertex location, and start instance location. So what's different? The base vertex. I don't really think that would have anything to do with it, because it's telling it the minimum vertex index, like the minimum vertex. Yeah, the minimum vertex number, I guess. Or vertex ID is probably a better way to say it. But, okay, I guess we should add that in. Maybe that is the problem. Okay, so the args buffer. So the minimum, we start at 0. Okay, and now this is 5. Technically, these are all unsigned integers as well. Okay, and then in the compute shader, I need to update the structure. So, okay, I have a start vertex index. So start index and okay, so yeah, this one didn't have a start index. It just has start vertex. So the start index is 0, but But anyway, I don't think that will make any difference because it's set to 0. It was set to 0 already, but okay, well now it's giving me an error, so I guess that's better than nothing. The variable cross compute shader doesn't exist anymore. I'm not sure what that error is about. Yeah, because it's still right there. Oh, okay. I guess that was the issue. But now, that's interesting. So it's not drawing everything. And that would make me think that we're having a buffer overflow or there's not enough like space to draw everything, but maybe the index buffer is too big. So it's running, because there's like a maximum size to buffers on the GPU, and maybe there's too many indices, so it's not able to draw everything. Oh, I guess I would figure out if that's the issue by changing this grid to be smaller. I guess this is a good example about why you might want to do instancing, but ooh. Okay, so that does work, I think. But it's like rotated strangely. But yeah, you can see there's a grass blade and it's not missing anything. Okay, well that's kind of a shame that when we have to add the indices it doesn't support our old grid anymore. Oops, that's supposed to be -90, but at least we're getting somewhere. I guess so what I would do here is I need to make a less sparse grid. And is there any way I don't really think there's any way I can get around this because I can't change the size of the index buffer. I'm kind of surprised that it's getting overflow because it's only one integer per. Let's see. So I guess I shouldn't be that surprised because we had like 60,000 vertices. So that means we had, well, it was the number of triangles. So it was like 16,000 times 6. So I guess that's too many. Let's see. So yeah, so it has, okay, well, it's actually 4,000 triangles. So it had 16,000 vertices and 24,000 indices, which I guess, like I said, is too many. Okay. Let's see. So, I mean, we could leave this how it is. And I'll shrink this and then add flowers, or I could try to do instance meshes, but because then I wouldn't need an instance buffer again. Let's see. Because oops. Yeah, there's this other draw mesh instance, and it basically just draws a mesh and repeats it multiple times. And you can use an instance ID. So basically, we would just use the instance ID to change each of the vertices on the mesh. But it's usually not a good idea to have like a small mesh with like thousands of instances. So I don't know. I'll need to do more that makes sense because, well, kind of, because a lot of times when you're having an error with like a buffer overflow, it tends to change, like the pattern where things aren't drawn tends to change because you don't know like the order that they'll be generated. But it's stable. But I don't really, it seems like, yeah, I don't really know. Yeah, it's a weird bug. I don't know why this could be happening, but we'll figure it out. Okay, is it something with the source mesh? Let's just try a bunch of different meshes. The thing about a lot of these default ones is they don't have very many triangles, but it seems like even this square, like you can see, it's supposed to be on a cube, but there's no blades popping out of the sides. Okay, and the capsule, yeah, so it even has weirdness. I wonder. Okay, so something is wrong. It must be wrong with maybe the number of source triangles or one of these IDs. So the triangle start, I think that's correct. Because every ID in here basically tells us one source triangle to generate a blade on top of. And for every source triangle, we generate one anchor. And the triangle start is the start index for this triangle, which is just the triangle ID times 3. I wonder if it's only getting one dispatch, maybe? Okay, let's try that by changing this to 256 and see if that changes the number. Okay, it doesn't, so it's not the dispatch number, I don't think. Because I was wondering like if it's only dispatching one thread, so it's only drawing 128 source triangles. But that wouldn't make sense either, because then it would change depending on the number of triangles in the source mesh. So it probably has something to do... you know what? Actually, this indirect argument buffer, I don't even need this anymore because... yeah, I don't... I know how many vertices are going to be in the mesh, so... yeah, I can get rid of that and simplify things a little bit. Okay, so I can just... it says draw mesh procedural, right? Then if I don't have a indirect argument... that does exist, doesn't it? Oh, right here. So draw mesh procedural, so it's the same thing except just without the indirect argument. And I pass the index count and the instance count. Okay, that's... yeah, I don't have... you know what? I wonder if I was supposed to pass the number of indices into the indirect argument buffer instead of the number of vertices. So it was only doing 2/3, which would kind of make sense because that looks like about 2/3. I'm kind of curious, so I'm going to just change this to add 6 and see if that works, but I think we can just get rid of... okay, so that was the issue. Okay, so that's good to know. When you're working with an index buffer, you actually pass the number of instances or indices per instance. But like I said, I can get rid of the indirect argument buffer for now because we don't really need it. So draw procedural, and the number of let's see, so okay, I want to pass the index buffer, and then I pass an index count and an instance count. So the index count is right here, so number of source indices times 6, and then there's one instance. Okay, and yeah, you don't need this 0 anymore. Okay, yeah, so we got material bounds, topology, index buffer, index count, instance count, camera. Okay, so that's all good. Well, before I do this, let's just comment out this so that I can go back to it at some point if I need to. Okay. So I could get rid of all this stuff with the indirect arguments. That's out of date. But I'll leave it for now. Okay, so yeah, that's good to know. If you're using an index buffer with draw mesh procedural, you count the number of indexes and not vertices, which makes sense. I kind of was wondering how that would work, but just didn't dawn on me until now. Okay, we can get rid of the indirect argument stuff. Yeah, and I'll just won't set that. Oh, well, I have to create it, but I. Okay, so let's see. Okay, so something is wrong now. The variable grass compute shader. Okay, so is this doing that same thing? Is there a bug in the compute shader? No. Oh, I just need to restart again. Okay, so now it's working. Yeah, sometimes you just have to press play to get it to refresh. So I can change this back to our dense grid. Okay, and there we go. We finally got grass blades. Okay, so now what I want to do, right now, they don't look like grass because they're just plains. What I'd like to do is make them transparent because basically each flower will just kind of have a little cutout texture that will apply to it. And the grass will also just be the same way. It'll have a little blades. So in order to do that, I need to I want to try something called alpha to coverage, which is a cool way that you can do transparent objects without needing you don't have to discard any, so it doesn't have to be a cutout, so you don't have to discard pixels, which is good because discarding is actually kind of slow. And then you also don't have to sort the triangles because alpha to coverage kind of treats them as opaque. And how it works is, well, I'll show you a good explanation of it, but basically it computes the transparency of objects at the same time as doing multi-sampling anti-aliasing, which kind of like blows up the render target, and then it does like multiple samples per pixel, and basically it checks to see how many samples in that pixel are transparent, and then that's how transparent it assigns that pixel, if that makes sense. But I have Ben Golis, which if you've been looking into tech art stuff, you've probably heard of. He's all over the Unity forums. He actually has this really cool article about it. So I just look up Ben Golis alpha to coverage, and I'm sure it'll pop up. So we're going to try to use this. So to enable it on Unity, I think all you have to do is put alpha to mask on. Why is it not letting me copy that? Okay, well, I guess I can just type it out. I don't know. Put it in the shader, and you don't have to change it to be a transparent, or into the transparent queue, which is nice. To mask on. At least I think this is how it works. Well, obviously we don't notice anything now because it's not transparent, but let's add some transparency to it. So this is just doing, so this last is the alpha. And so I'm just going to pass the X value. Okay. So now we've got some transparency. It seems like it's dithering, which is kind of interesting. But as you can see, this alpha to coverage is not really meant for like actual like gradient transparency like this. Is better for cutouts. So what you want to do, let's make alpha cutout variable. So I guess the alpha threshold. If I can type. So we want to clip this. What's the order of clip? I always forget. Or not clip, step. So what this does is if one value is greater than the other, it returns 1. If it's less than, it's 0. So it's basically alpha cutout. But I might have got these values mixed up. I always forget. Or the order anyway. But we can test that. But I need to add another property here. So alpha cut threshold, and this can be a range from 0 to 1. Okay, so right now the cut threshold is at 1, so it's not cutting out anything. Materials, grass blades. Okay, that actually works pretty well. Yeah, I thought that I was gonna have to do some fancy stuff with partial derivatives, but it seems to work already. But maybe that's just because it's a pretty simple shape. I'll go ahead and add that though. Oops, this opened in the wrong browser, but that's okay. Let's see. Yeah, because he shows. Scroll down a bit. Yeah, a lot of times when you do alpha to coverage, it gives you actually. We saw this dithering. So what you want to do to fix that, if you see it, is oh yeah, these banding, is you want to use f width, which is a partial derivative. We'll try that out. Here. Okay, so let's just do a float alpha equals. That's not what I want to do. I want it to be the input uv.x. Okay, and then you can change that to so again, if you don't know what this f width function is, you could go look up my partial derivatives video, which goes into depth about it. But actually, what it mostly is it looks out at pixels neighboring this pixel that it's working on and finds how much this alpha value has changed between pixels. And by doing this, you can kind of average out this value so that you basically get rid of the banding. You can see we don't really see anything here because we don't really have any banding in the first place, but you can see that it still works really well. Oh, but actually, yeah, this is not updated yet. Okay, so it's reversed about how I had it before, but that's fine. Do I want it like that? Because when it, oh yeah, because it has to be greater than 1 to be visible. So this is actually the correct way. I had it backwards before, but anyway, so when you zoom up really close, it seems like everything works fine. Okay, so now I guess we can make a grass blade. Probably for the flowers, I'll want to have like a flower texture, and we'll have like a texture atlas, and then we'll have the blade pick which texture to show. But let me see. I guess we can start on that. I'm trying to figure out the best way to generate the texture. I don't think I'll be able to draw. So like I said, I want to try to regenerate this. So I've got to make flower images. I'm not the best at that kind of thing, but it should be fun to try it out. I don't know if it'd probably be even more difficult to try to make it in a like Substance Designer or something. But anyway. Let's okay, so what I can do here, so if we want this alpha, if we want to make, I don't know, just a point, actually wait, before we do this we should add in wind. I just remembered that. Let's see, so I think I still have all the wind variables, or did I just delete them all? Okay, well that's kind of annoying because I'm gonna have to type them all out again, but okay, so we have, I think I've done this enough, but so we have texture 2D wind texture sampler sampler wind texture, and then we'll have the scale and tiling variable, which should actually be a float 4. Okay, and then I want a wind frequency, and a wind strength. And that's a float 2 because you can have the main wind direction and then also like a cross strength. Let's go ahead and just add like a wind direction variable as well. Why not? Okay. So we'll need the, I have to go after this because we need the position and the normal. So the wind UV, is first we'll need to transform text. I always forget if the UV goes first or the texture name, but it'll give me an error if it's wrong. So the wind will just rely on the X and Z position of the grass. And then plus an animation value, which we can get the time with time.y, and then time the wind frequency. Okay, and then we'll get some wind noise from the wind texture. So wind noise equals sample texture 2D, wind texture, sampler wind texture, and then the UV. And we just need the red and green components from that. Okay, so now the wind offset is the wind direction times the wind strength dot x, and then the other, I call it a crosswind, which I usually take the cross product of the wind direction and the normal vector. I don't know if I've done this in a video actually. I usually do something simpler, but I like the way this technique looks. So the normal world space. Why? Oh, right, and then I also need to multiply the wind noise. So wind noise dot red times wind strength. Okay, and I should normalize this actually, because otherwise it will have a sine, like it'll be scaled by the sine of the angle between wind direction and the normal, which we don't really want in this case. Let's be symmetric here and add wind noise, or multiply wind noise first. Not that it really matters. Okay, and now we need to scale the wind offset by the UV dot y, because we only want the topmost vertices to be affected by wind, and then we can add that to the output position, or position world space. Plus equals wind offset. Alright, so now I need to add these to the shader. Let's put it before the cutout, I guess. Actually, no, because the cutout, I'll put textures up there eventually, but... Okay, so wind texture. Let's call it the wind noise. Oops. Okay, hopefully I get the syntax right. It's kind of weird. So I think it's... Isn't it... That is for textures? I forget what this means. I looked it up one time, but nobody ever puts anything in there anymore. Okay, so wind frequency. Oh, and remember that these 2D things also come with a scale and offset, so we don't have to figure out that value ourselves. Okay, so float, and I'll set this to 0. No, I'll put it 1. So okay, and wind strength, and this was actually a vector. That's fine. And then, yeah, we have a wind direction, which, I don't know. We'll set this on the material for now, but probably you'd probably want to put this as a global vector, but. Okay. Uh-oh. Invalid subscript XY. I don't even have an XY there. Oh, okay. That's because I put these backwards. So I guess so this transform text is a macro, and all it does is take this, multiply it by the X and Y components of this, and then add the Z and W components. So if you put this before here, it tries to get those values from the wrong string. Wind texture ST. Oh, yeah, and I spelled that wrong. Or I put the wrong name there. Cannot map expression instruction set. That's an interesting one. I probably used the wrong macro. Let's take a look in the shader library and I can find the right one. Texture 2D. Okay, that's not probably not in there. Sorry, my nose is getting stuffed up for some reason. Sound even more nasal than normal. Let's see. Let input. I forgot. Yeah, the Unity's their URP library. They split things up a whole lot, so it's kind of hard to find things. I just want to find the sample 2D. Oh, sample texture 2D. Isn't that what I used? Oh, let's leave that open. Oh, right. This has to be sample texture 2D LOD. That's because... I should know better because I just did a video on this. That's because you can't use sample texture 2D in the vertex stage. That should be 0, actually. Okay, there we go. And now it's going crazy because the wind is like always blowing it. Oh, hi Wobsobby. How are you doing tonight? Sorry if I missed your chat message. The purple blended in with the background. Okay, so I need... Do I have the wind texture? Okay, good. I do have one already. Well, that looks kind of nice already, but let's... Okay, I see one thing I want to fix, but... Let's first shrink that down. I think it can go even more. Okay, and then of course the wind frequency is way too strong. Oh, one other thing I need to do, you can kind of tell that the wind is always blowing the grass. Consistently in one direction, and that's because yeah, I'm not unnormalizing this texture. So the texture ranges from 0 to 1, but I like to change it to range from -1 to 1. And to do that, you can just subtract 1 and multiply it by 2, or subtract 1/2 and multiply it by 2. So wind noise equals noise minus 0.5 times 2. You could also multiply by 2 and then subtract 1, obviously, but okay. So yeah, now it seems to be more centered. Does look nice, but you can kind of tell that the wind kind of compresses the blades. I don't really like the way that looks. So instead of using the anchor or the vertex position, I'm going to use the... Oh, that's interesting. Oh, no, we do have it. I was going to say I'm going to use the anchor's world space position. At first, for some reason, I thought we didn't have it, but we actually do have it. It's right there. So, oh. So it'd be anchor.position.world space. You're doing well. You found your channel from my YouTube videos. You're trying to learn how to write shaders. Oh, well, thanks, Wabsabi. I really appreciate that. Yeah, I've been programming for quite a while, so it's just a lot of practice. If you have any specific questions, I'd be happy to help. But yeah, I'm really happy with how many people my YouTube videos have been able to help, so thanks everybody for watching. I do appreciate it a lot. Okay, so this looks pretty good. I think that the strength is still too high. Did that change anything? Okay, it did. It just... And I think I actually accidentally changed the frequency. We can also change the wind direction, and I guess it'd be more visible if I actually enter play mode. That didn't actually do anything, did it? Oh. Okay. Yeah, I don't... That's because... Yeah, when you enter play mode, it created a copy of the material, so when I change it here, it doesn't update whatever is playing. It's... I have to do that because I want to be able to have more than one grass instance running, but you can see that when I change these, it does change the direction of the wind. So it's kind of a cool effect. You're still working your way through my grass shader videos, so you'll just observe for now. Alright, Wabsabi. Well, I hope you enjoy them. Yeah, feel free to, like I said, you can ask here or later on my YouTube channel. Oh wow, time has really flown by. I've already been streaming for over 2 hours. I think I'll go a little more. I might stop when it's time to do the texture because, like I said, I need to... Maybe I'll do those off stream, I don't know. I'm definitely more on the technical side of a tech artist, but I'm trying to fix that. Anyway, so we've got the wind. Excuse me. Got wind now. I guess, like I said, let's try to make some kind of blade. So it's not just a square waving in the wind. Okay, so I think what I'll do is we'll do a little math here and try to get the alpha to fade as the V value goes up so that the top will taper into a point. So I think what I can do, maybe it can just be as simple as okay, well, I don't think this will work, but let's see what it looks like. I can just subtract half the V coordinate. I think what this is, yeah, this is going to actually, oh gosh. Yeah, this is just going to make it, oh right, I can't use V, I have to use Y. But this is just going to make the, yeah, oh, actually that does kind of make a point, but it's not in the center of the blade. Hard to see. I should change that. Yeah, in perspective you can see it better. Yeah, so here you can see it's straight up, and that's because this is the I guess left corner. So what it's basically done is cut off an entire triangle, which is not really what I want to do. So what I should do here is make this value strongest at 0.5. So maybe something like, okay, I think, yeah, this isn't going to work either, I don't think, but let's see. Okay, so actually, if I change it to wireframe, okay, you can see that they kind of work, but they're way shorter, which is not really what we want. And actually, yeah, we can turn on shaded wireframe. Okay, you can see we basically made 2 little blades out of each. Okay, so I think what I should do, let's try something like 1 minus. Okay, that's better, but it's not looking that good still. Probably I have to scale it. So basically what I want is I want it to draw something from the bottom points up to, and then go up to the top. Like the center of the top. So I think right now it's turning or going below the threshold or going below 0 at like v equals 1/2. So I need to change it so it's v equals 1 is 0, but then also down here when x is 0 and 1, it should be 0 when v equals, oh, I just used both coordinate systems together, but sorry, when u equals 0 and 1, it should be 0 when v equals 0. Hope that made sense. So actually we might, well, we'll still have to use this, I think, but I think I just need to maybe just multiply this by 2. Okay, that kind of works, except it's not. Here we can see that there's or actually is the point? Yeah, the point is reaching the top of the billboard, which is what I want. But these sides aren't going all the way down to the bottom, so we need to. Oh, I already multiplied this part by 2. What happens if I don't remember doing that? So let's. What happens if I take that away? It's just filled all the way. Well, why is that going on? So when this is 1, I guess it just never goes down below 0. Let's see. When I change this, we can kind of see the shape. Oh, that's actually perfect when I set the alpha cut threshold to 1. So if I want to change it, so this happens when the alpha threshold is 0, I can just subtract 1 from the whole thing, I think. Yeah. Okay, so that's kind of cool. It doesn't really look. Okay, let's change off. Okay, I mean, it's kind of cool. It doesn't really, I mean, they look like pointy pyramids, but. Okay, well, let's get, I guess let's get ready to draw some textures, and then I can, maybe we'll do that next stream. Okay, so like I said, we'll have the alpha cutout, and we'll have oops, I guess main texture. I guess I can get rid of this base and tip color. Also, this blade curvature doesn't really do anything because every billboard only has 2. Like there's nothing in the middle to actually have a curvature. I just realized. Because what's supposed to happen is as you move up the billboard, each successive like row of vertices would move more in one direction, but right now, since we only have, since it says 4, it doesn't actually do anything. I guess maybe we can try to fix that. But right now, this texture is going to be more important. But yeah, we can get rid of these colors. So main texture. Let's do 2D equals, yeah, again, white. Okay, so I might want to do a normal map too, but that will make things a lot more complicated, so maybe we'll add that later. Okay, so I'm just going to copy this, get rid of the base colors. I like to have these in the same order that they appear in the shader. So main texture, and then the sampler main texture, and then we actually don't need this, so we can have a no scale and offset property here, and then it won't show up in the material inspector. Okay, so now everything is turned black because we got rid of the color properties. I'm kind of surprised it didn't throw an error there, but I guess because we haven't saved it. Okay, so we have the UV already. So I guess we can just get rid of this. Because the albedo and alpha will actually be what we get from the texture. So now we can just float for alpha, or let's say color equals sample texture 2D, then the main text, sampler main text, UV, or I guess it'd be input.uv. Alright, and now we can just use sampler texture 2D because we're in the fragment stage. Okay, and we don't need either of these anymore. I guess we still need this. Oh gosh, I don't know if you guys could hear that thunder. Didn't know it was supposed to rain. Okay, so color.a, we'll just put that, and then let's just make this easy on ourselves. So albedo equals color RGB. We'll rename this to main sample. Okay, so it should work. Undeclared main text. Oh yeah, because main texture, not main text. Okay, so let's just put in something random. I'll just put in the noise texture. Okay. Doesn't look good, but we'll take it. And yeah, so it does have alpha in it, so we can check to make sure alpha still works and it looks good. I don't see any weird banding there. This alpha to coverage worked way easier than I thought it would. This is actually kind of cool. It looks like paint splatters. But anyway, not the flowers that we want. Okay, so that wasn't too bad. Do we want to try and add a normal map? I think that would make things look pretty cool. It would definitely make the grass and everything look more 3D. But what we'd have to do is pass the tangent and the normal. Because it's not... So the normal map for this will be different than in here. it'll be kind of interesting because the normal will still point up, but it will be perturbed by a normal map. I only have like 20 minutes before I have to leave, but I guess we can try it and get started. So I passed the normal, so technically I would just need to pass a tangent, and then I could generate a normal map from that. Okay, so float for tangent world space is text chord 3. Again, you could probably do this better. Okay, so tangent world space equals, okay, we gotta do a float 4 because the tangent has that 4th bit. But yeah, I'll just not worry about that. Yeah, so tangent to world. And the tangent actually here is in the Y direction because that points outwards from the blade. Oh wait, no, actually the tangent is in the U direction. Right, but it's a little different here because now our normal is pointing upwards. But I think the tangent should point across the blade, so maybe it should be like this. But I don't know, we'll have to see. This is kind of weird because usually normal vectors don't perturb a normal that points straight up because that is already tangent to the blade. So I'll be kind of interested to see how this ends up looking. Anyway, okay, so we have this and we can pass it here. Tangent world space equals, and yeah, so we have that 4th bit, so float 4, which again just tells the sign of the bitangent. And basically that is if you're being left or right-handed. Okay. So Unity actually has some nice functions to generate the tangent matrix for you. I guess good luck me trying to find them. Maybe it's in space transforms? Oh yeah, transform object. Okay, that's not what I want actually, but transform blah blah blah. Okay, create tangent to world. That was easy. Okay, so float 3 by 3 tangent to world. And again, this is different than the one in the anchor because this is in like blade tangent space, not like source mesh tangent space. So create tangent to world, so that'd be input normal world space, input tangent world space x y z, and then we have to pass it the bitangent bit, which I guess we could just hard code in a 1 here, but I'll future proof this. Okay, so now we just need to use this. Well, first, I guess we have to read the normal map. Let's see. So I need to move that down here because this now depends on our textures. So float. Maybe, I forget, they probably have a macro to help with that too. It's like unpack normal or something. I don't know where that is in the URP library, so hopefully I can figure that out. So normal sample equals unpack normal. Sample texture 2D normal I guess call it a normal map, not a normal texture. And sampler, normal map, input dot UV. And I think I have to pass it as a normal strength. So we'll do that. Okay. I'm trying to remember. Okay, so we have transform world to tangent. So I need to take... Okay, so we can use this to... Oh yeah, we don't want that. We want tangent to world. So we can use this to transform the normal map. Normal into world space. And then we can like blend that. With the... Yeah, this is kind of strange because... Oh wait, no, I don't have to do that. I was gonna say we can blend it with this normal, but this normal is already pointing upwards. So yeah, this matrix will take care of that for us. Okay. Confusing myself there. I guess I've been programming for over 2 hours, so. Anyway. Okay, so now I can transform tangent to world, and this just, you know, deals with the tangent matrix for us. So float 3. Normal world space equals transform tangent to world. I guess technically this isn't the sample because we've unpacked it. So that's normal tangent space. Yeah, so we pass the normal and then the tangent to world matrix. And now this we pass to the lighting. Like that. Yeah, we actually don't need to normalize it. Okay, I think... Well, technically that will work, but now it's going to complain that there's not a bunch of variables. Let's add in the normal map and then a sampler normal map and then the normal strength. Float, normal strength. Okay, so I'll just, oops, duplicate this. And I want a normal strength. I keep pressing the wrong key. Okay. Okay, so now it's going to say unpack normal, isn't there? I have no idea where unpack normal is or comes from. Let's see. Put a core shader library. It might be, actually they do have like a packing. Does this have it? Unpack normal, unpack normal. I think they just have an unpack normal function that deals with all this. Yeah, and then the bump scale. Okay, I guess I have to call unpack normal scale. And then it chooses the right one for you depending on how Unity's set everything up. Okay, there we go. Okay, so now kind of interesting that some are black and some aren't. Okay, they all turn black when the normal strength is off. I wonder wonder why that is. Let me, I know I said I didn't have to normalize it, but let me see, because maybe you do have to normalize it. I'm not sure how Unity's functions work. Yeah, they don't normalize it there, but the normal strength might make it behave differently. Okay, well there's still some black ones, but I wonder if that's just because the normal map has nothing in it right now. So let's just make a dummy normal map that just sets everything to normal. That was weird. Sets everything to just a normal color, or the standard normal, which is this complete blue. Okay, save as. Normal test. Right, and then I can just go down to here and drag that in. All right. So now I need to tell Unity that this is a normal map. And now I can place it into the grass blades shader and hopefully... Oh, all it did was flip. That's funny. Okay, well, obviously something is not correct. Okay, so when I set the strength to 0 now, then they all work. Okay, let's test out the normal by just setting the color as the normal. So albedo equals normal, and it should, like, ideally... Oh. Okay, there's an error. Oh yeah, it's normal world space. Okay, well that's weird. Okay, so red means it's pointing in the X direction, which is in world space, which is like outwards from the blade. And, but then when we turn the strength down, everything is green, which we expect because that means it points straight up. But I don't know why it changes like that so abruptly. I probably got something wrong here. I could look up another shader that I've done with normal maps, but I don't really want to go find that file right now. Okay, packed normal. Okay, transform tangent to world. Did I maybe do this backwards? Let's check. Okay, no, it's the position and then the matrix. So normal and tangent space. I was gonna say maybe I should normalize before multiplying with a matrix, but that shouldn't make any difference. What about here? So I pass the normal, the tangent, and then the tangent sign. Maybe the tangent is wrong. Let me see here. I shouldn't need to normalize it because it's normal here. And the bitangent, it will just be pointing in the y direction there. Let me okay, that's right. Checking all my variables. What if... Okay, let's just try without the scale. I think it's just going to turn everything red, but yeah. So basically, yeah, when we set the scale to 0, that's how we expect, but it doesn't actually... Well, yeah, this scale might not do anything actually now that I think about it, because we're not blending the normal with anything. So, yeah, I don't think I actually... well, let's leave it. I don't know. We can test when we got it working. Let me think here. I don't really want to... I only have like 2 minutes, but I don't really want to leave you guys on a bug. Okay, let me open that other file and see if I can find that, what might be causing it real quick. Anyway, yeah, thanks everybody for coming by and watching the stream tonight. I got kind of more than I was expecting from my very first stream, so thank you. Well, I mean, technically it's not. I used to stream all the time, but this is the first one I've done the first one I've done in about a year. I hope it's gone all right. And again, yeah, I'd really appreciate any feedback anybody has on the audio or the overlay. Unfortunately, like, the audio won't be quite as good as my as my videos, because I can't do all the filters at, you know, quote runtime, but also I have these annoying like brace things on my teeth right now that make me kind of have a lisp, but I always take those out when I record videos. Let's see. Okay. Okay, so this one is impact normal scale. Okay, so I do normalize the... Huh, okay. Well, it's basically the same thing I'm doing here, so I'm not sure why this isn't working. Maybe I've got the normal map wrong, but anyway. We'll figure... I've got a... Unfortunately, my time is up. So yeah, I am sorry to leave you on this bug, but we'll continue this next time. Probably finish up this grass field. I'd like to, of course, finish the normal map, and then do some textures for the flowers, and so we should actually get something that starts to look pretty nice. And then I'll see about maybe we can... It's hard to... Yeah, this shader, one thing I don't like about it is that all the grass has to be on a triangle, so it's kind of hard to make good looking terrain. But actually, I mean, this field is all flat, so if I wanted to recreate that, we can do it how it is. But anyway, yeah, so I've got to sign off. Thanks everybody for coming by and watching. I really appreciate it. I'll be live again on Friday, same time, which is 9 Eastern. Yeah, check out my new video that just came out this morning. It's on animation and shaders, which we actually just used it to make the wind, so it's kind of cool. Or I used the technique anyway. I think that's about it. I'll put some links in chat if you'd like to check out my other social medias. I have like a Discord server where you can chat with me throughout the day. And yeah, I think that's about it. So thanks everybody again for watching. I do appreciate you coming to my first stream in a while, and I'll see you Friday. Bye-bye.